Hello, everybody. We'll just wait for another 4 minutes and then we'll start with the session. Okay. Hello, everybody. So, my name is Dr. Prerna Singh, and I'm an associate professor in EU Global. And welcome all for this session. And I'm just going to start the session. So, I hope that most of you have joined, and those who haven't, they can join in between. So, let's start with the session. I'm not audible. There is some issue. Can anybody please tell me, am I audible or not? Hello.
Yeah, hello ma'am, we can hear you.
Okay, okay. And what about before? Was I audible or not?
I think students are mute, all students are mute, so I think we have to unmute if we want to have the response from their side. I think they're
I think
already putting in the chat.
they are writing in the chat, right? Okay, let me share. Yeah, we have initially disabled the mic because we are starting with the session. And once we are in the middle of the session, because initially I'm going to explain you some of the topics, then we are going to enable the mics, right?
Ma'am, you can use the control button to make them.
Yeah, yeah, okay.
Okay, thanks.
Okay. So, in case if there's any issue, you can write in the chat window, right? So I'll be able to know that in case if there's an issue that comes up, right? So let us start with the session now. So first of all, let me just tell you that how I'm going to plan the session. As you know, statistic is very important for any kind of course that you're going to do. This is the base of artificial intelligence, right? So, for example, if in the future, if you want to learn machine learning or deep learning, you just have to know the maths first behind everything that goes in machine learning and deep learning. So here, statistic is one of the basic and very important module if you're interested in data science. So here, today, we are going to do maths behind statistic. So first of all, there are some of the core topics. If you see a course, if you have seen the course, as I've told you that once you have come to this particular session, it's very important for you to first go through the course, right? Which we have, that is statistic in data science. So as you've gone through the course, you can see that there are some of the topics over there which we have covered in this particular session, which we are going to cover. So the first thing that we are going to cover in this session is descriptive statistics, and in this we will be doing some of the case studies, because this session is going to be just case studies with little bit of theory planned for you to understand that why we are doing this, right? Then we are going to start after the descriptive statistic and explaining. Then I'm going to give you a short quiz, right? Just because that to tell you that you can test yourself just right now to see that how much you have understood this topic. So a short quiz will be given to you just for 5 minutes. Similarly, we'll be doing the second topic, which is visualizing data, in which we will be covering all the different types of graphs which you can see in the statistic. And since visualization is very important part, whether you are going for machine learning and whether you're going for further topics like Tableau or Power BI, visualization is a very important part. So in statistic, it is very important for you to understand that how you can represent your data with the help of visualization. After that, we are going to do the probability. In probability, we are going to cover the discrete probability and the continuous probability. So discrete probability will come the true probability, which is the binomial and the Bayesian probability. And in case of continuous probability, we will do the normal distribution, which is very important. After doing this, we will come to a very, very important topic, which like even the DBA student are using in their thesis when they are doing writing the thesis, The PhD students are using this topic, and as well as the MS data science student as well. We will do hypothesis testing, which is a very important topic, and you will learn that how you basically make an assumption and then you basically test that assumption, right? So here we are going to cover the four topics over here, four method, which is your Z test and your T test, then your chi-square test and your ANOVA test. So all these four methods, parametric and non-parametric, will be doing. And finally, we'll be concluding our session with regression. So in regression, we'll be covering two type of regression, which is linear regression and multiple linear regression. Okay. So since I told you that this particular session is more of practical, right? So I'm not putting a lot of theory over here. Just for your understanding, I have covered some of the key points, and these are just the formulas which I've covered for you, right? So I've covered some of the formulas for you in this particular presentation, right? So there's nothing like a lot of theory which we are covering. We'll be just covering the conceptual part, and then we'll be covering the case studies or a Excel file. In Excel file, we will be covering that how we actually implement this particular method in Excel. Okay. So I think I've given a brief overview of what the session is going to be, right? So let's start with the first part, right? And then start the session. So as you can see, in this particular, we are going to cover descriptive statistic. Descriptive statistic is very simple. That means if you have your data, or data in the form of the table, and if you want to show that what is the summary statistic of the data. So for that, what you can do is that you can find out the descriptive statistic, and based upon that, you can summarize your data, right? So for every column you can have a summary statistic, right? So in this, what we do is that we are going to first calculate that what is the measure of center tendency, the measure of dispersion. Then we are going to calculate the quartile and the interquartile range with the help of box plot. And then we are going to interpret the distribution based on the skewness, whether it is a normally distributed or whether the data is skewed, right? So you can see over here that I have already done that. Mean can be calculated. You already know this. I know that mean is calculated by the sum of the all data points divided by the number of the values. Similarly, for mode is actually that how much time that particular number occurs. So if it is occurring like 32 is occurring 2 times, it is the mode. And similarly, if it is bimodal, and if it is not occurring more than once, then we say that there is no mode. Median is actually the center. That means in order to calculate the median, first of all, we have to arrange the number in the increasing order, and then we have to calculate whatever is the center value, right? So then what we will do is that in case if the number is, we can see over there that 3 are on the left side, 3 are on the right side. So in odd, it is very easy to calculate the center value. But whereas with even number of data, then we will take this 2 center value and divide by 2, and that will be considered our median, right? Similarly, we can say that for the measure of central tendency, for the continuous data, we calculate mean, median, and mode. Even for the discrete data, we calculate mean, median, and mode. Nominal, we calculate only mode. So what is the nominal, ordinal, discrete, continuous, you will get to know when we will go further with the probability. Okay. So we can see over here that whenever we are going to measure the central tendency, we represent the different formulas based upon whether we are calculating the mean for the population or whether we are calculating the mean for the sample, right? In case if we are calculating the mean for the population, then we have to take it as mu, right? So this is a mu in case if we have to calculate mean for the population. Whereas if we have to calculate the mean for the sample, then we call it as X bar, right? And the formula also changes because here n represent the population, right? And here small n represent the sample. Similarly, for the variance is written as summation of this is xi, which is actually the value of a particular value which we are calculating minus the mean whole square divided by the number of the population, right? And similarly for this, we have n minus 1. Standard deviation is just the square root of the variance. So we calculate for both, right? And in case if we have to calculate that what is S square, we can do it with the help of this formula. That means whenever what is the data point minus the sample mean, and we will take the square of this. Then we will add both the values and divide it by the number of sample, right? So since the number of sample is usually a part of the population, so therefore we take the value n minus 1, right? And here we take the value n. So it is very important for you to just know that what this formula referred to, right? So next we will calculate that what is quartile and what is interquartile range. So quartile and interquartile range basically represent that if you have a data, right, how you can find out the median of the data. So the median of the data is called as Q2, right? And what is the first quartile? The first quartile is called as Q1, which is the 25th percent of the data. The third quartile is called as Q3, which is the 75th percent of the data, right? And then what you do is that you calculate. So this is the values that you calculate minimum. So you can see the minimum here is 66. Then you have Q1. So you can see minimum here is 66. Then you have maximum, which is 75. Q1 is the first quartile. So that is 25% of the data, right? And Q3 is the third quartile, which is 75% of the data, and Q2 is just your median, which is 69 over here. Now range is maximum minus minimum. IQR, which is interquartile range, is Q3 minus Q1, right? And this is the empirical rules for interpreting standard deviation. So what does that mean is that, for example, it says that if you make a normal distributed curve, right? For example, let's say this is the normal distributed curve, like, so what you can see over here is that over here in the center, we have the mean. So this is the mean, right? Then we calculate on the right hand side that this is mu plus, this is mu plus your standard deviation, right? And this is again mu plus twice of standard deviation, right? So in this, similarly over here, which is mu minus standard deviation, and here it is mu minus twice of standard deviation. So this is how you make your normal distributed curve, right? So this value is actually over here from mu minus standard deviation to mu plus. This is your 60% of the data, right? And from here to here, this is your 95% of the data, right? And over here, from this to over here, this is your 99.7% of data. So this is very, very important, because when you will go to the hypothesis testing, there you will have to draw this curve in order to find out that what is your lower confidence interval and what is your upper confidence interval. And from that, you will find out the critical value, and you will find out that whether your your Z score belongs to within the acceptance area or it is in the rejected area. So we will do about this, but this is just for you to understand that this is the normal distribution, and here we find out the mean. So mean here is considered as 0. So mean over here it's considered as 0. Okay. So we have to take mu minus mean and mu plus mean, right? So this is your 68% of data. And from mu minus 2 mean to mu plus 2 standard deviation, this is your 95% of data. And from here till here, it is your 99.7% of data, right? So now skewness. So when you're going to do you're going to do the descriptive statistic, you should know that skewness is actually the lack of symmetry. Suppose this particular graph which I made, this is just normally distributed. So it is having no skewness. But whereas if your graph is actually inclined toward a particular side, so we say that it is skewed. So when it is positively skewed, means that it is normally skewed to the larger values. And when it is negatively skewed, means it is actually skewed to the smaller values, or the negative, we can say it is negatively skewed or skewed to the left. So this is all for the initial part of descriptive statistic. So here in descriptive statistic, we did that what is the mean, what is the median, what is the mode. Then we did what is the range, right? How you define the range. We did what is the variance, how do we calculate the variance, and we did what is the standard deviation, right? So these are actually the three things, which is your mean, mode, median. These are actually the measure of central tendency, and your standard deviation, variance. These are actually the measure of dispersion, right? So this thing is very basic. Whenever you start learning statistics, this is the first thing that you learn, that how actually you have a data available. So how you're going to find out the descriptive statistic of that particular data. So what we are going to do over here is that now I'm going to open an Excel file, and in that Excel file, I am going to show you that how you can actually find out the descriptive statistic of the data set that is given to you. Either you can take a particular column and you can find out the descriptive statistic of that particular column, or if you want, you can take all the columns, right? So for this, it has to be mandatory that your columns have to be numeric, right? So you can only find the descriptive statistic for the numeric columns, right? Okay. So I'm just going to share the descriptive statistic. Okay. So you see over here, this is a small table, right? So this table is a survey. This is the case study I'm reading out to you. A survey is conducted amongst the urban professional to understand their income patterns, expenses, and saving goals, right? So based on the information given below, you are requested to apply descriptive statistic to summarize, interpret, and derive insight from the financial data collected. So what we see over here is that in order to actually use descriptive statistic, what you have to use is that you can go to the data over here, and this is this data analysis, right? This is actually, I have installed this. In case if it is not there in your Excel, what you can do is you can go over here, you can go to the option. Inside the option, you can go to add-ins, and in the add-in, you can actually use the Excel add-in. You can go, and here you have an analysis tool pack. So when you do a OK over here, then your tool pack is installed, right? So this is already installed because I've already added it by going to an Excel add-in. But in case if you have not, you do not see the data analysis tool pack in your data tab, there's nothing to worry. Just go to file and go to the option. Inside the options, there is an add-in drop down. Just click on the add-in drop downs, and in this you will get a box over there. So you just have to click on the add-in over there, and that particular this data analysis tool pack, and it will be added to your data tab, right? So after you have done this, it is going to give you the because I have taken these three values, right? The income, the expense, and the saving. So you can also find out for only for one column, but here I've taken the three columns because these three columns are the numeric columns, right? So see how it looks like. You do a data analysis. It is going to ask you that which particular data analysis you want to choose. Just click on the descriptive statistic and click on OK. So it is going to ask you for the input range. So the input range is going to be from the income to the saving. So that is going to be your input range. Then you have to use label in the first row because income, expenses, saving, these are the labels. You want it in the new worksheet, and then you have to apply that. What do you want to see? So you want to see the summary statistic. Okay. So for that, you are going to, that means it is going to see the entire statistic for all those value, confidence interval, for a mean, so that it is 95%. So 95% it is correct as compared to the population. Kth largest and kth smallest. Now what does kth largest means? Kth largest means the maximum value. Kth smallest means the minimum value. So you can see over there that normally when we are going to do a summary statistic, we already have a maximum value and the minimum value. So there is no need to have one over here. Simply what you can do is that you can put 2. 2 here means that you are going to get the second largest value and the second minimum value. So it's better to put 2 over there instead of 1 because it is going to give you the second maximum value and the second minimum value, right? So when you're going to do OK over there, you are going to get something like this, right? So what you're going to get? Something like this. So what does that mean? That this is income, which is in euros, expenses and saving. So you will get the summary statistic for all the values. What is the mean? What is the standard error? So what is the formula for standard error? Standard error is defined as standard deviation divided by square root of n. So what is n? N is the number of samples, right? So here the number of samples that we have over here is, we are having the 5 samples, right? So these are the, you can say that these are the 5 rows. So these are the 5 samples. So whatever is the standard deviation divided by square root of n, right? So that is the standard deviation, the standard error. Median. So median is calculated. How the median is calculated? So for mean, you can use average, right? Is equal to average formula. And for median, you can write is equal to median, right? For mode, there is no mode over here, right? Because you can see all the values are different. So standard deviation, for standard deviation, you can write is equal to STDEV. So this formula. For variance, you can write is equal to VAR, right? Then we will talk about these two things later, these kurtosis and skewness. Let's go to range. So you will find the minimum value and the maximum value. Just see over here, in the income, the minimum value is 3,500 and maximum is 5,000. So you can see it is 3,500 minimum and maximum is coming out to be, sorry, 6,000. So it will be 6,000. Similarly, sum is equal to sum. You're going to find the sum and then count. Count, you know, 5. Now largest 2. Largest 2 means the second largest. So here you can see the first largest is 6,000. Second largest is 5,500. Similarly, over here, the smallest is 4,000. So you can see the smallest was 3,500 and the second smallest is 4,000, right? So this is what it is. You're getting a value like this. Okay. So this is the confidence level. Confidence level is actually, it is 95. So you can also find the lower confidence and the higher confidence. So for this, we use the formula of mean minus confidence interval for the lowest confidence interval and mean plus confidence interval for the higher confidence interval, which is your upper confidence interval and the lower confidence interval, right? Similarly, for this, we have for the expense, for the savings, right? So what we do is summary statistic gives you a complete set of descriptive statistic. Confidence level is the range which basically is true for the population based upon the sample data set that we are using. So kth largest and kth smallest is 2. Mean is the average. Standard error is standard deviation divided by square root of n. Skewness, as we have already done, it is the asymmetric data, right? So that means when the data is skewed, it could be either skewed to the right or it could be either skewed to the left, right? So if it is skewed to the right, it is called as positive skewed. And if it is skewed to the left, it is called as your negative skewness. What is kurtosis? Kurtosis is actually that how heavily the tails have been distributed. So it's basically differ from the normal distribution. So distribution is having a heavy tail, which is a positive kurtosis. And when it is a flat distribution, then it is a negative kurtosis, right? So what is your lower confidence interval, which is mean minus confidence interval, and upper confidence interval is mean plus confidence interval. So this is all which we have understood for the descriptive statistic. So this data is given to you and based upon that you have find out the descriptive statistic for all the three numeric data. So this is done. So next I'm going to share one more Excel file with you. Okay. So you can see over here that this data is given to you. So this is I think 1,000 rows, right? So suppose if you have to calculate that what is the descriptive statistic for units sold and unit price, right? So this is the descriptive statistic for units sold, right? Similarly, you can do it in different sheets also, right? This is what it means over here. And this is the for the unit price, right? So you can see that how we have done the same thing. This is largest to the second largest value, and this is largest, smallest to, which is your smallest largest value, right? So we have completed the first part, which is descriptive statistic. Okay. So let me just open the, yes, now you can unmute yourself. Yes. So any kind of query with the first part before I start up with the second part, which is visualizing data. As I told you that after I finish a particular part, I'm going to give you a short MCQ session, which is just for 5 minutes to tell you that what you have studied, right? And it is going to be more interactive if we are going to do a MCQ session, because as we are going to move forward, the data and the content is going to be more complex. So initially we're going to start off with the basic, and then we are going to go to the moderate and difficult part, right? Which is also very important for your further courses also, which you'll be working on. So any kind of query which you want to ask me regarding the, that means if my voice is audible, if you're able to understand, how is my speed, you want it to be a bit slower, or you want me to move fast, you can share your views. You can raise your hands, you can write in the chat window, because the session is uh just for 2 hours. So we don't want you to waste your time, right? Okay. So what we can do now is that I can share the quiz with you and you people can do the quiz, right? So it will be a very simple quiz, right? Because it's very important to have an interactive session. So don't take a lot of time. Just take another like 5 minutes to complete the quiz, right? Yeah, I'm just sending you the link. So once I'm going to send you the link, you have to open the link and then I'm going to send you the code. You have to write that code and then the quiz will appear, right? So I'll just share it. So just write this on your, okay. So we are, just write this. Just a moment, I'm just seeing what is. So I would tell you, don't take a lot of time, right? In case if you do not know any question, just leave it and go start with the next one, right? Very basic questions are there. So you have to just write joinmyquiz.com. joinmyquiz.com, and then you have to enter this code. Then please enter this code, right? You can see, you just click on this link and then just write down the code. Just write joinmyquiz.com and then write down this code 297942. Please join the quiz fast. And I just give it for just 10 minutes, right? So we're going to start up with the visualization of data after this. Okay. Okay, only one student have joined. Please join fast, everybody. Okay, I can see 3 students have joined. Good. So this quiz is going to finish in 10 minutes. I just put a timer over here. Just join fast and just do the quiz. Very basic question, very simple questions. You know, only basic things are over there. By the time, let me open the second part of the boot camp, which is the visualizing data. Okay, so 7 minutes are left and only 5 students have joined the quiz. Yes, you can unmute yourself. You can write in the chat window and you can unmute also in case if you want to speak. I have enabled your cameras and your uh, chat window as well, and the mute button as well. Yes, yes, please unmute yourself and speak. Yes, please unmute yourself. I think it's by mistake he has raised the hand. Okay, 5 minutes are left for the quiz to be over. So I think most of you have completed the questions, right? Just 4 minutes are left. Three minutes are left. Yes, you can type, and even if you want, you can unmute also. Because now I've enabled all the mics. Initially, I told you when you're going to start the session, I'll be just muting your mic, and now you can unmute in case if you want, because now we're going to start up with the more complex topic, right? So the second topic that we're going to start up is your visualization of your data. Here, I have already made the graphs for you, right? So I will tell you that how you can interpret your data with the help of different graphs. So we have the scattered plot, we have box plot, we have the bar plot, we have histogram, we have the column chart. So all this you will see, and then we will go to the third part, which is the probability distribution to hypothesis and regression, right? This is a session on statistic Lando. So this session is going on where I have shared the PPT and we have done the first part, which is the descriptive statistic. Now I have given the quiz. You can see there's a link for the quiz which I have given, which is just about to over in 1 minute. And after the quiz is over, then I'm going to, I'll just share the screen with you to understand that since the quiz is going on. After this, we are going to start up with the next part. So this, you can see the quiz is going on. So the time remaining is just 1 minute. After the quiz is completed, then we are going to start up with the second part of our session, which is visualizing data. Okay, so just 1 minute, we'll start up with the new session. The first session is completed. After this, we had the quiz. Between second and third session, we will not have a quiz. We will finish off the 2 sessions and then we will have a short quiz. And then we are going to start up with the hypothesis testing, which is again very important part of this session. We have planned a case studies and Excel tool for you to work upon. You will get all the data that I have provided over here, right? So all the data and the recording will be provided to you. So now we have 30 seconds for this quiz to finish and start with the next session. The reason for giving you the quiz is that we don't want the session to be monotonous, because if I will only speak on and you will not get time to understand. But once a quiz is being given to you, it gets more like interactive session, and you can also basically understand that whatever is taught to you, you can actually check yourself also. You can do a self-evaluation. Okay. So the time is over. And now we are going to end the test. Okay, we can't give you time. Sorry for that. It's okay. So we have completed the test, right? So let me just view the reports. Okay, so accuracy is 50%, right? So the first is Nilesh. Very good, Nilesh. Excellent. He had a 76% accuracy. Second is Jordan. And third is Dushyant, right? And well done, everybody, all those who have attended the quiz. Really, very nice. So that's good. Now let's start with the next session. Okay. Now you please be there for the next session and try to understand that what are the different types of plots, right? So visualizing data. So this is the first plot that we'll be doing in the data, which is the scattered plot, right? So what is a scattered plot? You know that scattered plot means that when you have 2 dimension, right? And you have to find the relationship between the 2 features, right? So what you do is that you basically take a value which is X over here and this is Y over here. This X value is the independent data. This Y value is the dependent data. And you find what is the relationship between X and Y. So if the relationship is like this, means the value of X is increasing, the value of Y is also increasing. If the relationship is like this, that means if the value of X is increasing, the value of Y is decreasing, right? So it's a negative correlation. It's a positive correlation, right? And in case if the value is all scattered, we say that there is no correlation between X and Y, right? So scattered plot, this is a data set that is given to you. So this is a total bill tip. So we are to find the relationship between these 2 columns, right? The total bill column and the tip column, right? So what we say is that since the total bill is increasing, the tip is also increasing. So we have to find that whether there is a correlation between a total bill and tip. So this is also part of regression analysis, which you will do further. So whenever the total bill is increasing, the tip is also increasing. So we have to find that what is the relationship between total bill and tip. Is it a positive relationship? Is it a negative relationship? Or whether it is no relationship. So what is a correlation over there? So since it's repeating, so I'm just going to just take the slides, faster because almost the same data is there. So total bill is there and tip is there, right? So we are going to find the relationship between the total bill and the tip. So what we have to find? We have to find that if the total bill is increasing, is the tip also increasing? So this is like the total bill is coming out to be on the x-axis, which is the independent, and bill is going to be on the y. But tip is going to be on the y. But see, it is not mandatory for you, because you can also have a total bill on the y-axis and tip on the x-axis. So this is up to you. It is not mandatory to put the tip on the y and the total bill on the x, because any of the value can be dependent upon each other, right? But in case if it is provided that this is a dependent variable, this is what you need to find out, and this is the independent variable, then for that you have to make sure that the dependent variable will always be on the y-axis and the independent variable will always be on the x-axis, right? So similarly, is there a relationship between the tip and the bill? So this is how it is increasing, right? Is there so this is again the same thing they are asking you. So what they are going to do over here is that they are going to make a trend line. So when you add a trend line, you can see that this trend line means that there's a positive correlation. As the bill is increasing, the tip is also increasing, right? So this is the way we actually find out the positive correlation, right? Then we have the second plot, which is the line plot. Line plot is also basically tells you the continuous relationship between the points along the axis, right? So this is what the line plot tells you. So it is basically used to see for this, like for the total bill and for the tip, we do not use a line plot because it does not make any sense. It is not telling you in any kind of like story. For that, we have a scattered plot, right? So we didn't, there's no representation, there's no connection between the previous bill. So line plot is mainly used when there's a connection between the all the data points. Whereas in case of tip and bills, what the second person is actually having a total bill, there is no connection with the first person, right? So that is very misleading. So trend line is not there in the trend line is the correct way for putting the for the scattered plot. So trend line is used for the scattered plot and line plot is a simple plot. So what is appropriate? That means when we have a continuous relationship between the data points. So you just have to remember this, that which plot is important for which kind of data. So trend line is important if we want to find the correlation between the two data, and line plot is important if we want to know that whether there's a continuous relationship between the data points along a feature, right? So for a continuous, see, if you can see month, you can see there's a continuous relationship between the passenger and the month, right? So this is for this, we are going to make a line plot, right? So there, we know flights occurred between the years, right? So this is what they are going to find out, the passenger. So this is the passenger that they are doing. And this is that means the number of passengers are increasing as the number of year is also increasing. So this is for them, they have to create a line plot over there, right? Set as the number of year is increasing, the number of passengers. So it's a continuous knowledge. We can actually find out that initially at 1950, these were the number of passengers. Now in 1960, the number of passengers have increased. So that means we are having we are also having a dependency on the previous data that we are having. So for this, we are using a line plot, right? And in case if we want to have it for different month, so we can also have a line plot for different months over the year for different passengers, right? So then we come to a distribution plot. Now this distribution plot is a histogram, right? So histogram is also used. It's a kind of a distribution plot, and it is a plot in which the bars are connected with each other. So it is very important to know that histogram is used for the continuous data. Now, what is continuous data? Continuous data means the data which can be broken down into a different value. For example, let's say height, a person height, or let's say weight. A weight can be from 67 to 68. So weight could be 67.5, 67.9, right? So this is the continuous data, right? Which can be broken down into a smaller values, right? Whereas when we say a discrete data cannot be broken down, like number of children. So number of children can be either 3 or 4. We cannot have 3.5. So that is a discrete data, right? Whereas the continuous data, it can be like we can have a middle values also. We can have the range. That means from 35 to 36, we can have 35.5, right? Similarly for, let's say, the height of the person. So height of a person can be 5 feet. It can be 5.5 feet. So it can be 5.6, right? So this is how that's a continuous value. So for the distribution plot, we are using a histogram. So we know that it is for the continuous. So you also have to remember that which plot is used for which kind of data, right? So you can see that this is the distribution data, right? So okay, so this is for the total bill and count. So this is the count and this is total bill. So this is the distribution data, and they are all actually, the bars are connected with each other. So here you can also have the histogram for this, right? So next we have the categorical data. This categorical data is actually a bar chart, right? So this categorical data can be a bar chart, which could be a something like this, right? So what is the expenditure per day? So this is a simple bar graph over here, right? And similarly, you can have a horizontal bar chart and your vertical bar chart, right? So now what we have is that I have already uh, got the data for you. So this is I'll be sharing this file with you, this Excel file. So in this Excel file, okay. So this is the Excel file. So these are all the charts that I have already made for you, because if we are going to make it over here, this is going to take a lot of time, right? The time is limited, right? So let me just explain that how we actually made this particular bar chart and this particular plot, and why it is necessary for what kind of data. So you can see over here that we have this table. This is the item count. This is the order total, right? And this is, we have created a scattered plot over here, right? So scattered plot is basically carried between a value which is on the x-axis, which is the independent value, and the value on the y-axis, which is the dependent value. So item count is on the x-axis and order total is on the y-axis. So then this we have a equation of line. So what is the equation of line? The equation of line is called as y is equal to mx plus b, right? What is y? Y is the dependent variable, x is the independent variable, m is considered as the slope, right? That means as the value of x is changing, the value of y is also changing. And b is called as your intercept, right? So we can also calculate the value of m from this formula, though you don't have to remember the formula, but in case if you want, you can just understand that this formula is m is the slope. The higher value of m means the line is going to increase faster, right? A negative value means that it is going to decrease. And B is what? B is the point where the intersect the vertical axis. So it is called as the intercept, right? So a particular value is given to you, right? That means if you can see over there, n is the total number of values. So value is 25. Then you have summation of x and y. So x is your independent value and y is your dependent value. So you can see over here, this item count is your x. So what is item count? Item count is your x. So this is your x value and this is your y value, right? So here you have taken the total item count. You have done the total, which is 138 of this. And here the total is $1,229.38, right? Then whatever is the value, we have done the square of this, which is coming out to be this. We have also multiplied both the x and y. We have actually the count, we have done count square. So this is the value. Then we have multiplied count by order total. This is the total value that have come. And then we have find the total. So this all is done. Then what we have did was that we take these two column. We went to insert. In the insert, we went to the scattered plot and we actually created a scattered plot based on these two values, right? So this we will not do it now. We already have created the scattered plot. After, these are the points that we get, right? So you can see these points we get based on the value of x, we got the value of y, and we have added a trend line. So this is the trend line. So if you just do this, it is removed. So this is the trend line. And if you want, you can also consider from this trend line, you can find out that what are the different values, right? So this is the equation of line, which you can see the B is the intercept, M is. So based on that, you have found that M is 7.312 and your intercept is 8.8063. So this is the first part of a relationship between the two variables, right? The line plot. So line plot is also one part in case when we say that when there's a continuous relationship, right? So we can say like for January, this is the temperature, how the temperature is first increasing, is reaching to a point and then decreasing. Two line plots, suppose if you have the two different type of temperatures, so you can also have a two line plots like this. Histogram, as you can see that you have different intervals, right? And this is the population. So if you want to see the continuous data, you can make a histogram. Bar plot is simple, that there's a horizontal bar plot. This is the categorical data. We use a bar plot, and this is your vertical bar plot for the continents, and this is the count. So this is for suppose if we are having for summer and winter, the continents, right? So this is the bar plot for the continents in summer and winter, right? That means there's a count of how many how many number of people have actually participated in summer and winter, right? And this particular plot is very important. It is called as a box and whisker plot. So this is very important to know that what is box and whisker plot. So have you used box and whisker plot before? Any of you? You can write down in the chat window. Have you used a box and whisker plot before? No, you have not used. Any one of you? Anyone else have used the box and whisker plot? Okay. So what I'll do over here is that I'm just going to create a box and whisker plot, right? Tell you that how we actually create this, right? So what we do over here is that this is a data 1 and data 2 that is given to you, right? So we are going to create, that means we are going to analyze data 1 and then we are going to analyze data 2, right? So what we are going to do is that first of all, we are going to find the minimum value. So minimum value is calculated from this. You write the formula is equal to minimum and you find these values. So you get the minimum value. Then is the first quartile value. So you can see over there that what you write is equal to minimum, and you do this and you just take your this data and then you basically, so you get the minimum value. This is Q1. Q1 is called as the quartile one. So for this you have the formula quartile. So you write quartile and then you just take these data and then you just get the, okay, I think what happened. Okay, then you take the quartile and you find it 1. That means you want to the first quartile. So you put 1 over here, right? So you get the first quartile. In quartile 2, similarly you write is equal to quartile, right? Then you basically take the data, the entire data, and this is what? This is the second quartile. So it's also called as medium. You write 2 over there. Similarly, for Q3, you write third quartile and you go for the data 1 and data 2, right? So this is the table that you get based on data 1 and data 2. Next, what you do is that you find these, you make this table out of this table that you have. So this table is called as H1, H2, H3, top whisker, bottom whisker. So what is that H1? H1 is actually your Q1. So whatever is Q1, you just write over here in 23, right? H2 is what? This is the formula that I've written for you, Q2 minus Q1. So H2 is Q2 minus Q1. It is coming out to be, Q2 is your 67 minus 23. So it is coming out to be 44. H3 is Q3 minus Q2. It is coming out to be 15. Your top whisker is max minus Q3. So you have to remember this formula, right? Bottom whisker is Q1 minus Qn. Similarly, you will do for this. Now what you will do is that you will just take H1, H2, H3. You will go to your insert. In this, you will go to your clustered stacked. You will go to your stacked column. After this, you will go to switch row column. So this is what your bar looks like, right? So you will go, this is what after switch row column this is. So you will just take the lower one, the lower quartile one, and you will just going to do a no fill over here, right? That means you do not want any fill. So you will just simply remove this. So you can also go to the format over here and you can simply write over here that you do not want it. So you just remove this, right? You will take this. Then what you'll do is you will take the bottom whisker. So you will again go to the chart design, add chart elements. Then you will go to your axis. No, you will go to your this error bars. You will go to more error bar option. Here it is minus, right? Then what you're going to do is you're going to take a cap. You are going to take a specify value. In this negative option, you are going to take the bottom whisker value and do OK, right? Similarly, you will take a top whisker over here. In the top whisker, you are just going to calculate the, again, a more error bar option over here. Okay. So then you are going to have more error bar option. You're going to have plus, cap, and in custom, you are just going to specify value. So in this positive, you will have the positive value, right? And do OK over here. Okay, just something is equal to, and you will specify the top whisker value and do OK. So this is getting your top whisker value, right? So this is how you are going to create your box plot. Okay. So this is the way you are going to have your box plot, right? So once you have done this, right, then we are going to tell you the third part, right? So we have now the third part of our boot camp, which will be your probability, right? So this is again, that means the first part we did was the descriptive statistic. The second part we did was actually the visualization of the data. And the third part that we are going to do now is your probability, right? So let's start with the probability. Can you see the slide, everybody? Okay. So in the probability, we are going to start with what is probability, right? Probability is actually represented by the occurrence of data, right? So a probability can be a discrete probability and a continuous probability. Discrete probability means the probability which is countable, which cannot be divided into different values. Continuous probability means a value which that means a random variable that can be divided into different values, right? So discrete means the number of eggs that a hen lays. So that is discrete. The number of students in the class, that is discrete. Continuous means something which can be in decimal. So that is continuous, right? For example, height, weight, that can be in decimal, right? So this is again for the probability. This is the formula that you have to remember, that what is the mean, what is the variance, right? And what is the standard deviation. So these formula you don't have to remember as such, but you should know that what does this mean actually, This is, I have already told you that this is actually a normal distribution, and your data lies within 68% of your normal distribution, which is from mu, which is your mean minus standard deviation to mean plus standard deviation. 95% of data lies between mu minus standard deviation to mu plus standard deviation, and 99.7% of data lies between mu minus 3 standard deviation, mu plus 3 standard deviation, right? So this is the first probability that we are going to do, which is called as binomial distribution. Binomial distribution basically represent the fixed number of trial. All the trial must be independent. Each trial must be classified into two categories. So here what we do is that in what we do in the binomial distribution is that in the binomial distribution, we basically have, let's say, in the binomial distribution, we have P. So P is the number of success of trial. So suppose 0.8 is the success. The number of trial is 10, right? So what is going to be mu? The mean is going to be N into P. What is going to be the variance? Variance is going to be, suppose, then what is going to be the failure? The failure is going to be 0.2 if 0.8 is the success, right? Which is Q, which is also called as 1 minus P. Okay. So this is what we have NPQ, which is the variance, and your standard deviation is square root of variance. Okay. So this is one case study. That means 80% of the business have a success, and there are 10 number of trials, right? So the probability of success is given to be like, this is for a value, that means n is 10, p is 0.8, q is 0.2, right? Number of success among n trial is 7, right? So this is given that there are exactly 7 are actually 7 out of 10 IT startup will generate a profit in their first year, right? So number of success in n trial is X, which is 7, right? So from this formula, though this formula is not required when you have to do it in the type of in Excel, but you can calculate this. That means n factorial divided by n minus x factorial. So based on this, you can find out the value of probability x is equal to 7 for the binomial distribution, right? So this is the binomial distribution. This is the formula for the expected value, which is NP, and for the standard deviation, it is NPQ, or it is NP 1 minus P, and this is going to be the square root of that, right? Similarly, we have a Pearson distribution. Pearson distribution is used when we are talking about a specific interval, like a car appears, how many number of cars appears at a particular interval, right? So a random, so in this we have a random variable x, which is the number of occurrence. The occurrence is random. The occurrence are independent of each other. The occurrence are uniformly distributed. So this is the formula that we use. Mu to the power of x into, this is the value of exponential minus mu. The value is actually 2.71 divided by x factorial, right? So then we have the next, this is what the Pearson distribution looks like. It first keeps on increasing and then it decreases, right? Then we have the standard normal distribution, which is actually the graph is bell shaped. So this is actually a standard normal distribution. So the mean is over here. This is 0, right? So this is all about the probability distribution, right? So next we are going to start up with the uh, graph, right? So what we are going to do now is that I'm going to share the Excel file with you. And in this, we will study that how we are going to make the probability distribution, right? So let's take this example. So in this, you can see over there that this is what a probability binomial distribution looks like. The probability of a man hitting a target of a shooting is 1 by 4, right? That means 0.25 is the success rate, 0.25, right? So the failure rate is 0.75. N is 10, right? If he shoot 10 times, what is the probability that he hit exactly 3 times? So when he is shooting n times, what is the probability distribution function and your cumulative distribution function? So in order to find the probability distribution function, you use this is the formula that you have to use. You have to remember this. This is your binom dot dist. C13 is the value of your this value, 0. This value is called as P, right? What is the value? This value, and this is the N, right? That means this is the value of this is the value of number of occurrence, and this is the success, right? And false will be here. For the probability distribution, we will use all false. The same formula will be used the cumulative distribution, but instead of false, we will have true. Why true we will have? Because we are, suppose if this value 2, it will depend upon the previous 2 value. This value 4, this will depend upon the previous 4 value. So the same formula is used where C16 represent the 3 value, right? And C10 represent the number of occurrence, which is 10. And this C8, here we are using a dollar signs because this value is fixed, right? C8 represent the 0.25, which is the probability, right? And true because it's a cumulative distribution function. Then we have make the graph. We have taken the this value and the probability distribution function. We have made a column chart out of this, right? And you can see over here that in case if you want to make it a like if you want to make it like a normal distribution for a value like this, we can also make it for a cumulative distribution function. So what we'll do is we will just make a graph like this. We'll just select this. We will go to insert. We will do a recommended chart, and suppose this is what the recommended chart it is giving you. So we'll just delete this one, and you can see over there what this means. This means that this just represent the values which is of this value and the cumulative distribution function. So graph look like this for a cumulative distribution function and look like this for a probability distribution function. So this was your binomial distribution graph. Now we come to the Pearson distribution graph. Now, as I told you, Poisson distribution, which is a discrete distribution, right? We always have a discrete distribution, which is your probability distribution, the binomial distribution, and the Poisson distribution. So here, people arriving in an hour is a Poisson distribution. Phone calls in a day is a Poisson distribution. Potholes in the road is a Poisson distribution. Number of cookies in an ice cream is a Poisson distribution. So suppose if the probability of 4 mice per week, number of mice per week is lambda, which is 1. So it's 1. That means a number of mice that can be caught in a week, mean is lambda, which is 1, right? Now we have to calculate that what is the probability of 4 mice per week. So obviously the probability of uh, that means 1 mice per week is going to be this, right? We have to find what is the probability of 4 mice. So we are going to first take this till 10, 0 to 10. 10 will definitely will be 0 because 4 we have the value is increasing till 4 and then it decreases. So we can see over here, we use a formula Piscian.dist. I13 is this, the value which is over here, which is 0. H10 is actually the value which we have over here, which is 1 and false. So from this, we calculate this value. As you can see that first the value is increasing when we are going from 0, 1. At 2, it is decreasing. At 3, it is decreasing. Now see, I want to tell you one thing more is that if this value keep on, suppose if this value is 0.35, right? Then you can see the chart is different, right? The chart is also different. Similarly, if this value is 1, suppose if this value is, let's say, 7, you see the chart changes exactly. So as the value is increasing, it is getting more like a, you can see over there, it is a asymmetric chart, right? Suppose if the value is 4, right? This is how it becomes like a normal distribution. If 4 mice per week, so what is the, for 4 mice, it is just like a normal distributed chart, right? So you should know that as you're changing the number of mice per week, your chart is also changing, right? The third part, which we are going to do, which is very important, is a normal distribution. So normal distribution is like for an MBA grade, these are the MBA grades, right? Which a person has got, right? So we have to find the mean. The mean is this. We'll use the formula is equal to average. For standard deviation, we use the formula STDV dot P because this is the population, right? From this, we are going to create a sample data. So this we will take from 60 to 100, right? And we have an interval of 2, like 60, 62. Then we are going to find the normal distribution. So normal distribution, again, you should know this formula. It is equal to norm.dist. E3 is 60 value. C4 is the mean of this. And this is a standard deviation and false because we are not, the previous value we are not dependent upon. So we will use the false. Then we will take this value and then we will go to insert. And in the recommended chart, we will create a normal distribution chart like this. So it is a normal distribution you can see over here, right? So this was all for the third part. So we have done the 3 parts now, as you can see that we have done in the boot camp. We have done the descriptive statistic, we have done probability, we have done visualization of data. So now comes a very important part, which is hypothesis testing and mechanism. This is very, very important. And since it's already been like one and a half, it's going to be like more than 1 hour, right? So we are just going to start up with this because this is going to take a lot of time, right? But this is very important even for the PhD scholars. This is very important, those who wants to do like the DBA scholars and the PhD. This is important because once you are doing the quantitative analysis, right, then it's very important for you to do a hypothesis, right? You have to do a hypothesis testing, whether you have to write an assumption first, and based upon this, you have to basically test a hypothesis. So even if you're writing a research paper, right, whenever we write a research paper, we make an assumption that whether this hypothesis is true or not, right? Whether we have to reject the hypothesis or we do not have to reject the hypothesis. So even for when you're writing a research paper, it's very mandatory and very important part of a research paper. And for the MS data science students also, this is very important. So let's start up with this. That is hypothesis testing. This is very, very important. So please, in case if you have any issue, just let me know. I will explain you again, right? So let me just start up with hypothesis testing and mechanism, right? So what is hypothesis testing? So hypothesis testing is a part of inferential statistic, right? It is basically used to draw the conclusion. See, why do we do hypothesis testing? Because let's say we have a population data. Based on the population data, we cannot make hypothesis testing because it is very difficult to test the entire population data. So what we do is that we take a sample data. This sample data is a part of a population data, right? And it is the less number of data, right? Suppose if the population is, let's say, the population data that we are having is like 1 crore. So it's very difficult to actually take the entire data and check it. So suppose if we take that value of 1 lakh, so then it's very easy to check the 1 lakh with the help of hypothesis testing, but it is not possible like to take the entire population data and to check it, right? So here we basically focuses on unknown parameters like mean, variance, standard deviation, and it's basically used for data driven decision, right? So this is the initial part. So hypothesis testing is that we have certain rules which we have to follow for the hypothesis testing. So it's basically says that if we have to do a hypothesis testing, we have to first of all make the assumptions regarding the population parameter. Then we have to do a certain number of steps and we have to see that whether we reject the hypothesis or whether, so there are two things, whether we reject the hypothesis or whether we do not reject the hypothesis. So there are two, whenever you write, you never say accept the hypothesis. You say do not reject. So these are the two outcomes that we have after hypothesis testing. So the first thing that we do in hypothesis testing is that we have to know what is the null hypothesis. So this is the default assumption, which means that there will be no effect or there will be no difference. When we say that means null hypothesis, it is always H2. So that means there will be no difference. It will be exactly the same. Whereas for alternate hypothesis, it is H1. So which means that there will be a difference, which contradicts. It is alternate hypothesis is always the opposite of null hypothesis. Significance level is alpha. So this is a threshold value. This is very important for you to know when we'll be doing the normal distribution, what this alpha means. Test statistic is one of a type of hypothesis testing. And p-value is again a probability value, which is used to find out whether we reject the hypothesis or we do not reject the hypothesis. So this is the mechanism to do hypothesis testing. First of all, we define the null and the alternate hypothesis. Then we collect the sample data and we compute the test statistic. Then we determine that what is the significance level. We compare the test statistic to the critical value and use the p-value. We reject the hypothesis or we do not reject the hypothesis, right? So let's say H0 is that definite is not guilty. So not guilty is obviously the null hypothesis. So what will be the alternate? That means he is guilty. It is the opposite, right? So we need to have a evidence to reject the null hypothesis, right? So that is what we want. We want to reject the null hypothesis. But if we do not get that evidence, we do not reject the null hypothesis, right? So this is an example. Suppose a college has an average pass percentage of 85%, right? Sample is 100 student, average is 90, which is your mean, right? So mean is written as your X bar, right? Sample is written as n, small n. Standard deviation is 4%, right? So H0, which is null hypothesis, means that mu is equal to 85, right? And what is your H1? H1 means that mu is not equal to 85. So it is always opposite of your null hypothesis, right? And then we have to perform a Z test, which is a hypothesis testing. So hypothesis testing is of 4 types, which we will do. We will do a Z test, we will do a T test, we will do a chi-square test, and we will do a ANOVA test. So this is the type of 4 type of testing that we will be doing, right? This is also called as your F test, right? So we will doing all these 4 tests, and these tests are used for different types of data sets, right? So what is the formula for Z? The formula for Z is X bar minus mu upon standard deviation divided by under root n. So this is the formula for Z. X bar is the mean of the sample minus mean of the population divided by this is what? This is the standard deviation of the population divided by under root n. So n is your number of samples, right? So here what we do is we compare the x to the critical value. For the 95 confidence interval, the critical value is plus minus 1.96. If the value of z you get is greater than 1.96, we reject the hypothesis, else we fail to reject the hypothesis, right? So this is the what we have done in this previous slide. Next is p-value. P-value is the probability value, right? So probability value is also part of inferential statistic. Here we calculate the p-value. If the p-value is less than, so what we do is we calculate the p-value if it is less than 0.05, which is your what? Which is your alpha, which is your significance value. So if this value is coming out to be less than, then we reject H0. So this is important. If P value is less than your alpha, alpha is given. Alpha value can be 0.05 if the value of confidence interval is 95. So if confidence interval is 95, that means alpha is 1 minus 0.95. So it is 0.05. If the confidence interval is, let's say, 99, then your alpha is 1 minus 0.99. So that is 0.01. So you know the value of alpha depending upon your confidence interval. So this is a very important part of, that means you will find the value of P. If P is less than alpha, if P is less than your uh, alpha is your significance value, you're going to reject the null hypothesis. But if P value is greater than or equal to alpha, then you do not reject the null hypothesis. So you fail to reject the null hypothesis, right? So similarly, distribution confidence interval. So now we will come to the this formula. You already know that if it is less than, then you reject the null hypothesis, and if it is greater than, you fail to reject the null hypothesis, right? So now we come to a Z test. What is Z test? This is the first test of a null hypothesis. When do we do it? This is very important. Whenever our sample n is greater than 30, and whenever the standard deviation is given, we always do a Z test. So you should remember, when do we do a Z test? Whenever our sample value is greater than 30 and whenever a standard deviation is given, right? Greater than equal to 30, right? So even if it is equal to 30 and if a standard deviation is given, we will do a Z test. Z-test is a statistical method which is used in hypothesis testing for large samples. It is used when the population standard deviation is given. So this is a population standard deviation, right? It compares the sample mean to the population mean and determines the statistical value. So it is used when your population standard deviation is given and when sample size is greater than equal to 30. So Z-test, this is known. What is T-test? T-test is done when your sample, what is sample? N is less than 30. Okay, then we do a t-test. And when your the population standard deviation is not known. But what standard deviation is known? The sample standard deviation is known. So this is the difference between a z-test and a t-test. In z-test, the sample has to be greater than equal to 30 and your population standard deviation, which is this. And in t-test, your sample standard deviation and your value of n is less than 30, right? Chi-square test is used for the categorical data. So here we have the observed value and the expected value, right? So we have O minus E, right? Whole square divided by E. So this is for you will do in the chi-square test. ANOVA test is again used in case if you have to compare the variance of multiple groups. So these tests are used for just the categorical data. This is for the categorical data and these are for the two groups. But this is used if we have for the multiple groups, like 3 or more number of groups. So for that, we use a ANOVA test. I hope this is clear to all of you, right? That when do we do a chi-square test or when we do a ANOVA test, right? Is it always null hypothesis or there are other two? See, there is always null hypothesis. This is how we actually uh, uh, do our hypothesis testing. The first thing we do is that we always write a null hypothesis, right? So after writing a null hypothesis, we basically do that if whether we have to find out the alternate hypothesis. Alternate hypothesis is just the opposite of the null hypothesis. This is the first thing that you have to do when you have to do a hypothesis testing. Okay. Okay, that's great. So now we are going to do the type of statistical testing. So we will do all of them one by one. Z test we will do, T test we will do, chi-square, ANOVA we will do that, right? So let us do a case study over here. Now see, we will do the case study from starting till end and find out that whether the null hypothesis is rejected or whether the null hypothesis is not rejected, right? So first understand the case study. The average height of all residents in a city is 168 centimeter and the standard deviation is 3.9. So you can see over there the average height of all residents. So this is your population mean. Standard deviation, this is your population standard deviation. The doctor took an average height of 36 individuals. So this is your sample. This is N is 36, right? To find the average height to be 169. And this is your average height of sample, which is average mean, which is 169.5. Calculate the null and the alternate hypothesis. At 95% confidence interval, is there enough evidence to reject the null hypothesis? So we have a population mean. Is this? This is your population standard deviation. Sample of 36 individual, mean is equal to 169.5, right? Test at 95% interval, is that mean heights differ significantly. So your null hypothesis states that mu is equal to 168. That means there is no difference. Alternate hypothesis states that mu is not equal to 168, right? So this is just the opposite. So here we are writing not equal to, so it is considered as a two-tailed test, right? Because it can be whenever we are going to have the, let's say the normal distribution curve, the value can be let's say less than and the value can be greater than. So that is why it is a two-tailed test. So we will use a two-tailed test in this. So here we are going to find out the significance value. Confidence interval is 95. Alpha is 0.05. As I told you, alpha is 1 minus 0.95, right? Here we have a rejection region. So it's whenever we have to write a so this is the region 95%. It is accepted region, and this is 0.025, and this is also 0.025. This is your rejected. So this is your rejected region, this is your rejected region, and this region is your accepted region, right? So then we have to find that what is going to be the interval, right? So what we're going to do is that we will use a formula of 1 plus Ci divided by 2. So Ci, confidence interval, is 0.95. So we get a formula of 0.975. Or we can take 0.95 plus 0.025. So we get 0.975. Then what we are going to use? We are going to use a Z table. In the Z table, we will find what is 0.975. So it will be in 1.9 row and 0.6 column. So we will get 1.96. So if you want, I will show you the Z table, right? For you to understand that what does a Z table means. So let me just go to you over here and show you that what is a Z table. And from the Z table, you can find out this value, right? So as I told you that we have to use a positive Z table. So in the positive Z table, you will find this value as 1.9. So you can see the value was 0.97. Yes, this was the value 0.975. So you can see on the left hand side it is 1.9 and on the column it is 0.06. So it is 1.96. The value is 0.975. So that is why you get a value of 0.975 over here, right? This value that you get 0.975, it is at 1.96. So now what you get your Z value, whatever the Z test you will do, and based upon the Z test, if your value is right, you will compare it with 1.96, right? So based on that, you are going to reject the null hypothesis or you do not reject the null hypothesis. So now we have a formula Z bar minus mu upon standard deviation divided by under root 10. Based on this, we will find the Z bar. So Z bar is coming out to be 2.31. So 2.31 is going to be greater than your 1.96, which you have calculated from the Z table. So if this Z value is greater than this, then we will reject the null hypothesis. So this is the first thing that we did. Secondly, we did was using a p-value. So this is the critical method that we have used for rejecting the hypothesis. This is the first step. The next step is getting a p-value. Then we are going to compare the p-value. That means we are going to calculate that 0.014 we will get. Then we are going to multiply this by 2 for the two-tailed test, because if we can see over there that this value was 2.31, right? This value was 2.31. This is positive, this is negative. So here we have 0.0104 and here we have 0.0104. So how do we get this? We get this from the Z table. So you would come to know that how we are getting this value. This we are getting from a Z table, right? So with a two-tailed test, then we will multiply this, we will get this value. Now this value 0.0208 is less than 0.05. So therefore, when a p-value is less than your significance value, we reject the hypothesis. So that means we have done the two tests over here. One is the Z test. In the Z test, we have used the critical value, right? So this is the value which we have used, critical value 1.96, and based on that we find out that whether we rejected. So hence we rejected the null hypothesis and then we calculated the p-value, and based upon the p-value also we rejected the hypothesis. So this is how we did the entire case study, right? So Z value and p value together confirm the decision accuracy. If the low p value means that we reject the hypothesis, if there's a higher p-value, that means we do not reject the hypothesis, right? So this is what the Z test gives you, right? The next test that we have is the T distribution test. T distribution test is used when your n is less than 30 and when the sample standard distribution is not given. Sorry, the population standard deviation is not given. So this is the student T distribution is used when the population standard deviation is unknown and we have a small sample size, and when we do not have the n is less than 30 and the sample size, that means the standard deviation is not given, right? So for this we have a different formula. But for example, we have this, that means instead of the n over here which we have the s. So we do not have the standard deviation, that is not given, but we have a s, small s, which is your sample standard deviation, which is given, right? So formula will be changed. Instead of this, for a population standard deviation, we will use a sample standard deviation, right? So this is how it looks like. You can see that there was a value of population standard deviation, but now we are going to use a sample standard deviation, right? So here, whenever we are going to do the t-stats, we will always calculate the degree of freedom. Now, what happened is, why degree of freedom? Suppose we are using 10 sample, because I tell you that in sample, we always use n minus 1, right? So we will use degree of freedom as 9. Now, what does that mean is, for example, let's say, why we take this, suppose there are three, let me just go back to where we were. Yeah. Suppose we are actually three people and there are three chairs. So the first person will get three options, the second will get two options, but the last one will have no option because the one chair which will be left, he have to sit on it. So only how many people have the freedom? So there is only two people who have the freedom to choose. So therefore, DF is taken to be n minus 1, right? So therefore, we have to calculate for the T distribution, we have to calculate DF n minus 1, and based on that, we will find from the T table, we will find the value, right? So we are going to find the critical T values, and rows will be the degree of freedom, column will be the tail type, that whether you have to use like two tail test or one tail test or the left tail test, and based on that, we are going to find out the T test value, right? So let's do this case study. This case study is very important because as we did for the Z test, we will do the same for the T test as well, right? So in the population, the average IQ is 100. A team of researchers want to test a new medication. So average IQ is 100. Okay. So in a population, so what we are telling you is that mu is equal to 100. right? This is what? This is your null hypothesis. Mu is equal to 100. This is null hypothesis, okay? Now, what it is saying is a team of researchers wants to test a new medication to see if it is either a positive or a negative effect on intelligence or no effect. So here it means no effect, okay? So sample of 30 participants who have taken the medication has a mean of 140. So X bar is coming out to be 140, right? Sample standard deviation is given. So therefore we will do a t-test, right? So sample standard deviation S is given to be 20, right? N is given to be 30, right? Alpha is given to be 0.05, right? So mu is equal to 100 is going to be your H0 and H1 is going to be just opposite of your this, which will be just opposite, which means that mu is not equal to 100, right? So we are going to just have this mu is equal to 100. Alternate hypothesis is mu is not equal to 100. It is a two-tailed test because see, whenever we are writing not equal to, it means it can be either greater or it can be less. So it is always a two-tailed test, right? Then what after the null hypothesis and the alternate hypothesis, we are going to find the degree of freedom. So they are 30. So degree of freedom is 29, which is n minus 1. Then we are going to have alpha and for degree of freedom. Now we are going to calculate from the T table. So let me just tell you what the T table looks like. For this, you will require a T table. And based on this, you will have to find out the, see, it is 29. So you will go to 29 and it is a two-tailed test. So you will go to 0.05 and you will see 2.045, right? So this is the value of your T critical value, right? So it is 2.045. So if you see over here like this is 2.045 positive. This is minus 2.405. This is your accepted area. This is this one and this one. If it is less than point minus 2.405, or if it is greater than 2.045, then it is rejected. Then we will do a t-test. We will find out the value, which is 10.96. So 10.96 is greater than 2.405. So we reject. We can see over there that 10.49 is 2.5. So we do not reject the null hypothesis, right? It falls in the rejection area, right? So it falls in the rejection. Okay, it is falling because it is greater than, right? So null hypothesis is greater than, for this, it has to be less than. So therefore, we are going to reject the null hypothesis. That means that the medication that is given is having an effect on intelligence, right? So similarly, we can see over there that we have done a t-test, and from this we calculate that what is the t value. The t value comes out to be 10.96 and the t critical value was coming out to be 2.4. So whenever a t value is greater than the t critical value, then we actually reject the null hypothesis and we say that it is saying that there is no difference. But yes, there is a difference on the medication and the intelligence, right? So what is the difference between t-test and your t-test and a z-test? The difference between a t-test and a z-test is t-test is used for the less number of values and z-test is used for more number of values, right? And here we are going to do the output. Now, what is the output over here? Let's see. Let me draw you a confusion matrix. See, this is a confusion matrix, right? So that means reject the null hypothesis. This is the first thing we do. We reject null hypothesis. So that is the first thing. We do not reject. So this is a confusion matrix, which you should know we do not reject, right? So here what we do is that this is true and this is false. So see, suppose if we reject the null hypothesis, but the null hypothesis is true, then this is an error. This is not good. We are rejecting the null hypothesis, but the null hypothesis is true and we are rejecting. So this is called as your type 1 error. So this is normally asked in interview that what is a type 1 error? That means you're rejecting a null hypothesis which is true. This is a type 1 error. You are rejecting a null hypothesis which is false. So this is fine. This is true. That means that you're rejecting a null hypothesis which is actually accepted. So this is true. Okay. Or we can say this is okay. Okay. We just write. Now you do not reject a null hypothesis. This is true. You do not reject. Is it true? And you do not reject. This is also fine. This is also okay. You do not reject the null hypothesis, right? And it is false. That null hypothesis is false, but you do not reject. So this is called as your type 2 error. So this is also called as your confusion. This is also called as confusion metric. So when you will be doing the machine learning course, then you will be understanding that what is confusion metrics, right? So this is your type 1 and type 2 errors. It's occur in hypothesis testing because sometimes what happens is that you reject a null hypothesis, but it is true. So that's a type 1 error. And you do not reject the null hypothesis, which is false, which is called as a type 2 error. So the reality is the null hypothesis can be true and false. So you accept or reject the null hypothesis. So correct decision means this is correct, desirable output. You reject when it is false. You reject when it is true. This is type 1 error. It is also called as false positive, right? When you fail to reject when H0 when it is false. So this is type 2 error. So this is a false negative, right? Reject H0 when it is true. So this is your desirable outcome, right? So now we come to a very important type, which is Bayes theorem. So what does the Bayes theorem says? It's a part of naive Bayes, which we will do in machine learning. So what actually probability consists of independent event and it consists of the dependent event, right? So probability is of two type, independent and dependent. What is the independent event? Independent event means that when you take a dice and you roll a dice, so every time the frequency is going to be the outcome is going to be 1 by 6, 1 by 6, 1 by 6. So this is your independent event. But whereas what is your dependent event? Suppose if you have a marble, in this, the yellow, there are three marbles yellow and the red is there are two marbles. So this is the three marbles are yellow and this is having two marbles are red. So first of all, you took a red marble. So probability of red marble is going to be 2 by 5. This is total outcome. Now you took a yellow marble provided that red is already been taken. So probability will be 3 divided by 4 because now only 4 are left, right? So that is why you say that this is called as Bayes theorem. So what does the Bayes theorem says? Bayes theorem say probability of A and B is equal to probability of B and A. So this is commutative. So probability of A multiplied by probability of B such that A has already occurred is equal to probability of B into probability of A such that B is also occurred. So from this we also find out the Bayes theorem. So this is taken as the formula as P. Okay. So this is taken as the formula as this, that probability of y such that x1, x2, x3 has already occurred, right? So this is also taken that if one probability has occurred, then that means whenever we have to find the probability, it is also taken as probability of the previous value. So if one probability has occurred, then what is the next probability, right? So this is also called as the Bayes theorem. So this is a conditional probability theorem and it is also used when we are going to do the naive Bayes. So for example, we have taken that probability of probability of A and B. So probability of A and B is written as probability of B and A. So this is similar, right? So probability of A and B means probability of A multiplied by probability of B such that A has also occurred and probability of B multiplied by probability of A such that B has also occurred. So now what we will do is we will take this A in the denominator part. So probability of B such that A has also occurred will be probability of B into probability of A such that B has already occurred divided by probability of A. So this complete formula is called as the Bayes theorem. Similarly, from here, if we have probability of y such that x1, x2, x3, right? So this will be given by the formula as probability of y into probability of x1, x2, x3 such that y has already occurred divided by probability of x1, x2 and x3. So this is called as the Bayes theorem. It only means that once this is the independent probability, this is the independent probability, and this is the dependent probability, right? Next, we come through confidence interval and the margin of errors. Confidence intervals, it's basically defined the range estimate, right? So point estimate is a single value from the sample, and it is also called as X bar, right? It's a sample mean, right? If we have to calculate the point estimate plus minus margin of error, so for this, we have a formula. That means point estimate is defined as the value. So if we have a value of point estimate, it is written as X bar plus minus Z of alpha by 2 into standard deviation by n, right? So this is the formula which we have to calculate, right? So we have a case study over here. And this case study says that on the verbal section of CAT exam, the standard deviation is to be 100. A sample of 30 tests have mean of 520. Construct a 95 percentile CI about the mean. So we have a popular standard deviation of 100. Sample size n is 30. Sample mean is 520. Confidence interval is 95. So from this, we'll get the Z value 1.96, which is from the Z table. So you can see over here, this is going to be your graph. This is going to be your 95%. This is going to be minus 1.96. This is going to be plus 1.96. This is the rejection area, which will be 0.0 or let's say 2.5%. This is also going to be 2.5%. So then we are going to use a Z table. And from this, we have 520. This is 1.96. So 1.96 into 100 divided by, so this is the number of value. This is standard deviation. 1.96 is going to be your this Z, this value, right? Multiplied by the uh, standard deviation divided by under root 10. So 39.2 is the value. Lower bound value is 520 minus this 4. So these are your confidence interval. This is your lower confidence interval and this is your upper confidence interval, right? So this is how you find the lower confidence and the upper confidence interval, right? So then we are going to do a third test, which is a chi-square test, which is again a categorical data test. So this is a categorical data test and it's very simple. It is used for the nominal and the ordinal data. So what we do in a chi-square test is we have the observed distribution and the expected distribution. So suppose in a lab of 75 students, 11 are left-handed. Does the class fit a theory of 12% of people are left-handed? So you can say that in the science lab of 75, so out of 75 students, you can see over there that how many of are left-handed and how many. So we will have the observed value and we have the expected value, right? So in the observed value, you can say this is the left hand and this is the right-handed. So 11 are observed to be left-handed. So out of 75, how many left right-handed are 64? Expected value is 12%. Now 12% of 75 expected value, it comes out to be 9. So 9 are going to be left-handed. So how many? 66 are going to be the right-handed expected value. Then based on this, we have another problem. That means goodness fit test. So what does it say? That there is a 2010 census and these are the values that less than 20 kg, 50 kg was 20%, 50 to 75 was 30%, and greater than 75 was 50%, right? So based on this, we have also calculated, this is for the 210 census, and for 220, this was the sample size of 500, and less than 50 kg was 140, 50 to 75 was 160, and greater than 75 was 200. So based on this, we find the expected value and the observed value, right? So the observed value that we had was the this is the observed. Now let us see for the observed value for 2010 that we have for less than 50 is coming out to be 140, right? For 50 to 75 is coming out to be 160, and greater than 75 is coming out to be 200, right? So this is your observed data, right? Similarly, for expected values that we have, which we can see over here, which is like 20%. So we can see over here for less than 50, 25, 20% of 500, because 500 is, so it is going to be 100, and for 50 to 75, it will be 30% of 500, so it will be 150, and greater than 75, it is going to be 50% of the 500, so it is going to be 250, right? Then we are going to use the formula, right? So this is the observed data, right? Hypothesis means the population weight distribution is not changed, and it is saying it is changed, right? So value of alpha is given to you. Based on this, we know that we will find. So we have this, the 2 is your DF, and 0.025, 0.05, we will have a value of 5.991, right? So if your value of test statistic is greater than this value, you're going to reject the hypothesis, right? So you will use the formula of x square is equal to summation of O minus E whole square divided by E, right? So in this, we have the observed value. In this, the observed value is found and the expected value is found. And based on that, we are going to take this. So observed value is 140, expected value is 100. And we will get these values. We will add this, we will get 26. So 26.66 is greater than 5.99. So therefore, we will reject the null hypothesis. So this was the chi-square text to reject the null hypothesis. So what does it mean? It says that the weight of 2020 populations is actually different from the expected value of the 2010 population, right? So we reject the null hypothesis. Okay. So now the last test is the ANOVA test, which is based on factors, levels, and we will do the ANOVA test, which is basically used as analysis of variance. It is used to compare the 2 or more groups. So in this, we will compare 3 or more groups. So we have the factor, for example, let's say factor is like medication. So medication is the factor, right? Levels is like 15 mg medicine or 20 mg or 30 mg. So these are the levels, right? Like medicine is a factor, the levels are different types, 5 mg, 10 mg, right? Similarly, for the mode of payment. So mode of payment is a factor, and level is that whether it's a phone pay or a Google pay or a demand draft, right? Then we have the assumption. Assumption, that means we can only do a ANOVA testing if it's normality. Normality means that it is having a normal distribution value, right? This is the first thing which we have to assume. Second is there should be no outliers. So outliers can be removed in case of the data set. Homogeneity of variance. That means when we are taking 3 levels, the variance of 3 levels are homogeneous. They are equal, right? Independence means the samples can be independent and they can be randomly selected. So these are the 4 assumptions of the ANOVA test. Now we come to the partitioning of the ANOVA test. So what is the ANOVA test is used? So here we are going to do a hypothesis which says that all the groups means are equal. And the alternate hypothesis means at least one group mean is different. So at least one group mean has to be different in order to do an alternate hypothesis, right? So variance between group divided by variance within group, right? So F statistic, we use the formula of variance between groups and various group. So larger F represent greater difference between mean, which is evidence against your H0. So here we are going to do a steps where we are going to define H0 and H1. We will do a significance level, degree of freedom. We will do the, that means whatever is SS in between, and we will do that whatever is the degree of freedom within. And finally, we'll do a F statistic, F test, and we will conclude it. Now let's do the last case study. Doctors want to test a new medication that reduces headache. They split the participant into 3 conditions, 15 mg, 30 mg, and 45 mg. Later on, the doctor asked the patient to rate the headache between 1 and 10. Are there any differences between the 3 conditions? Now, medication is the factor and levels are this, right? So this is the 15 mg. We have taken 7. N is equal to 7. 7 people have rated it from 1 to 10. 7 here and 7 here. Then we have taken 3 dosage groups, 7 participants. So total is like 21, right? And outcome is the headache reduction score, right? So DF between. So DF between is taken to be K minus 1. So total is 3 minus 1. So which is 2. DF within the sample. Between the sample, you can see between the sample is K minus 1, which is 3 minus 1. Now within the sample is 21 minus 1. So 21 minus 1 is going K. Sorry, 21 minus K. So 21 minus K is written as 3. So it is taking as 80 value. If you're going to add these two values, we'll get the total DF, which is going to be 20. Then we are going to calculate the critical value. So for DF at 2 and at 18, we have alpha as 0.05. The critical value is coming out to be 3.554. So if the F calculated is greater than 3.554, we are going to reject the null hypothesis. So what we'll do is we have 18 over here, which is DF, and here we have a value 2, and the value is coming out to be 3.5546. So we will do what this? We do it in a chi-square table. So we have a we have a F distribution table, which is your ANOVA table. And based on the F distribution table, we find this value of F critical, which is going to be 3.5546, right? So here we calculate the value, right? If you want, I will draw a table for you to understand it more better, right? So what we are going to do is that we have that means SS, which is the between sample. DF is your degree of freedom. Then we have mean square, and finally we have the F value, right? This is going to be between sample. This is going to be within sample, right? And this is going to be total. So between sample, we have a value coming out to be 98.67, right? This is going to be 10.21 and total is going to be 108.95. Similarly, DF is going to be 2 over here. It is going to be 18 and this is going to be 20. Here it is going to be SS, whatever is SS divided by DF. So here the values come out to be 49.34. Here the value is going to be 0.54 and here it will going to be added as 5.4475. So here we will divide this by this value and we will get a value of 86.56, which is greater than your 3.554. So therefore we are going to reject the null hypothesis, right? So here we are taking the entire value, mean square value. So therefore we reject the null hypothesis, right? So this is all the same which we have already done, right? So that means we have completed the null hypothesis. And as we do the next part, which is regression, which we have already completed. So let me just go through it. So I hope hypothesis is clear to everybody that how do we write the null hypothesis. So this is the last part, which is the regression. So regression is again, it's two type of regression is there. One is your linear regression and other is your multiple linear regression. So as we already told you that when we find the relationship between two values with the help of the scattered plot, and in this we have a linear regression. The linear regression is basically checking that what is going to be the that means here we have only two variables. So one variable is the x, another variable is the y. So that is linear regression, right? But what is multiple linear regression? Multiple linear regression, we have your many variables. So we write y is equal to mx1 plus mx2 plus mx3 plus mx till any plus b. So here always dependent variable is always one, whether we are doing a linear regression or whether we are doing a multiple linear regression. But the independent variable are many in case of multiple linear regression, and in case of simple linear regression, it is only one, right? Next, I'm going to show you the output of your multiple linear regression, right? If you can see over here, I'm going to open Excel and tell you that how do multiple linear regression look like. So this is the data set that was given to you, right? So based on this data set, you have to find out that whether length 1, so these are the 5, weight, length 1, length 2, length 3, height and width, right? So all these variables have the impact, right? So this is what we need to find out. So what we did was we calculated all the values, right? We find out that what are the independent value and what are the dependent values. So here the output is going to be the weight. The weight is going to be the y value, and length 1, length 2, length 3, length, height and width are going to be the. So you have to draw, like you have to go to data and do data analysis, and then it is going to ask you that what you want. So you can do over here the regression and do OK. So it is going to ask you the y value. Y value will always be the value which is dependent. X value can have many variables. So therefore, we are going to take all the values from length 1 till width, right? And other, it is all exactly the same as we do in descriptive statistic. So as you can see over here, we have multiple R. So it is 90. R square is coming to be 0.89. So that means 89% it is having accuracy, right? And then we have this, the intercept is coming up to be minus 609 point. So this value is the B value. Now, what is important is to see the p-value in case of regression analysis. Suppose if the p-value is less than 0.05, that means that this variable has a significant effect on the dependent variable, which is the weight. But here you can see length 1 is 0.77, which is greater than 0.05. So it is not having any effect. Even if we, that means adding this variable to multiple linear regression is giving a negative output. So we should remove it. Length 2 is having a value which is greater than 0.05. So again, it is also not having any impact on the dependent variable. Length 3 is having a value of 0.07, which is greater. So it is also not having an impact. Whereas if we take about height and weight, the p-value of height is 0.002, which is less than 0.05. So it is having an impact on the output. And width is 0.04. So this is also having an impact on the output, which is your dependent variable. So this is all. I have completed all the 5 modules. That means we started with descriptive statistic, then we went to the that means visualization, to probability, and then finally to hypothesis testing, and to the last part, which is regression analysis. So I have covered all the parts. So I hope you have understood and enjoyed the lecture. And if you have any question or answer, you can let me know. Yes. If there's any question answers that you want me to ask me, you can let me know. Okay. Okay. Thank you so much. Okay. Thank you so much. So now I'm ending the session. So I had really a wonderful session with you all. All the concepts were explained, though the time was limited for such a big syllabus, but I made sure that I would like whatever the time was there, I made sure that all the concept was actually explained to you in a very elaborative manner, because as you know, these concepts are going to be very helpful to you. This is all maths you have studied over here, maths for data science, right? So all these statistics is going to help you out for your further sessions also, because this is one of the basic part of your data science. Thank you so much. Have a nice day. Bye.